tech community. And welcome to the DFI Podcast with my co-host, Ishan Chordia, and our fabulous guest today, Michael Fischer. Thank you for joining us, sir.
Hello. It's a pleasure to be here, Wes and Ishan.
Thank you so much for taking time out of your day to join us. Longtime friends from the DeSci community, and we've got a lot to talk about. We want to learn about DBDAO, what DBDAO is up to, and everything that's going on in the ecosystem. One of the best places to start, because I actually don't even know this, even though we spent a lot of time at conferences and working together, I'd love to hear your background before you got into Web3 and crypto. What's your journey? How did you get into the space?
Yeah, well, I grew up in Santa Cruz and was at Stanford for undergrad, and then I finished the PhD at Stanford also. I was studying computer science. So I had a lot of background in academics in general and AI and natural language processing. I got interested in some other things like the intersection of AI and the law. So just like thinking through when a self-driving car crashes, and I wrote a book on that. And then based on all that sort of stuff, I realized that it would be really interesting to do. I saw the potential that crypto had to perhaps change some of the things that are the way research is done. And I saw a model where it was like, oh, instead of just like paying people for their time, maybe there's a way of like fractionalizing the result. Maybe there's a way of incentivizing research in new ways instead of just through this sort of archaic, like getting credit and on the paper and then using that credit on the paper to get a job or something like that. So I just saw an opportunity, or I saw a way, not an opportunity, but I saw a way to do scientific research and to do academic research in a way that was much different and not necessarily better or worse, but just something that was different than the existing way of doing it. Yeah. So my background was, when I was doing the PhD, and was on natural language processing, and specifically like how to convert between natural language and code. So you could like describe what you want to the computer, and then it would then take that and convert it into a small app for you. And sort of the dream was, it would be really cool if you could have an Alexa style device and you could tell it something you'd want it to do. And then if it didn't have that recipe or a skill already built, it could build it dynamically. And so we sort of finished this research before, ChatGPT came out. But that was the goal of the research, and now it's great because ChatGPT is able to very much do this very well now. So that's kind of my background.
That's an incredible alignment, especially since Ishan and I spend a lot of time in the AI space, AI and Web3. There's probably a lot to dig into that. What were you surprised at all when ChatGPT came out? Were you expecting it at all, or was that sort of advancement something that you could see coming in the field?
Yeah. I mean, we were using ChatGPT 2. We were using GPT-2, and then GPT-1 was open source. GPT-2 was also open source, and we were using that as sort of the basis for a lot of things that we were doing and trying to like re-refine it. And then, I always thought it was going to happen. I think I was a little surprised that it happened so quickly, but I think most people, there's no reason it wouldn't happen, I guess. I thought it would take a few more years, to be honest. I thought it would take 5 or 6 years, but it came out like 2 years, came out much more quickly than we thought.
What made you think that it would take longer? Is it just the amount of horsepower that you need, like processing power for the training, or advancements in the algorithms?
Yeah, I mean, there's just a lot of little things that have to work. And I think probably what made it actually work is that Sam Altman and OpenAI sort of vertically integrated everything and put enough horsepower behind actually making it work. So you didn't have to work piecemeal on these sort of disjunct parts. And with that sort of efficiency came faster ChatGPT. Would be my guess. I mean, there's probably lots of reasons. If you had to ask me, that would probably be it.
Well, that's a good rabbit hole to go down. I'll try to bring us back. Ishan, I'll give you some space if you have any thoughts there related to AI.
I'll jump in. Yeah, didn't like GPT-4 need like 10,000 GPUs or something like that to get 100,000 GPUs? Something ridiculous, like something you were like, wow, that cost them like $100 million just for hardware. Like that's crazy.
Yeah. 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 You said a good thought. I mean, one thing that's interesting with AI is we're starting to incorporate that more into DeSci, decentralized science. So, well, we can talk more about it, but one of the projects we started was a DeSci accelerator called a Sci Combinator. And maybe we can talk about it now or later. But
Yes,
basically, we
please.
started a
Yeah.
lot of, I started DeSci NYC, which is sort of a DeSci, find out more about it at DeSci.nyc. And, we were seeing a lot of people that were we had monthly meetups, and we still do have monthly meetups. And there was people that wanted to get more and more involved in DeSci. So we started this program called Sci Combinator, obviously an allusion to Y Combinator. And, Sci is like a science that has a lot of interpretations in science in many different disciplines. So like we started this program, and what's interesting is DeSci is accessible to a lot of people, right? So that's the goal, is like not just people who are accepted into a university are part of DeSci, but anyone is accepted. Anyone can start a DeSci project. But however, sometimes you need like specific skills in order to do analysis or do data analysis for science. And one of the things that we encouraged the people in the cohort to do was to use a code interpreter when now analyzing their data, because it makes it so that anyone can be a scientist. And I think DeSci is now sort of encompassing just like using distributed technologies or AI, like in order to bring more people into science. So DeSci, and originally was like about how can we use the blockchain or distributed ledger technologies or new types of incentive mechanisms to do new types of science. And one of the things that I think is really interesting about DeSci also is like there was this whole movement around open science previously. And open science was like, okay, I'm going to do science, and then I'm going to give the science away for free. And I hope people give me credit or whatever. But the problem is like, imagine like Uber was like like, I'm just going to give people rides for free. It would never work. Like you have to pay people to do the thing. So what's cool about DeSci is, what we're doing at DBDAO is like you have to pay in order to get access to a data set. And what's neat about that is that it creates a market for data to happen. So that now you're in sort of incentivizing data. But in addition to that, with this AI thing, we're also seeing it like DeSci can also be about just like bringing more people into science and incentivizing them, but also allowing more people to use these sort of new tools like a code interpreter in order to analyze their data.
Very cool. I think we talked about this once, Wes, but like decentralization has technical decentralization, economic decentralization, and legal decentralization, right? These are like the three things that we generally think of. And so I think for a long time, the Web3 community was like technical decentralization was like the main thing, right? But because of blockchain and like decentralized software, like running nodes and everything, I think it's interesting that you mentioned that like it's just not that. It's actually like incentives for like, for different use cases in science. One being like access to data, sharing more data, getting more people into science, creating better incentives for, data to be shared or more people into science or whatever. So I just to that for me was like super interesting.
Yeah.
To hear about.
And when people ask about what is DeSci, it's like, it's kind of like asking what is DeFi. Like, it's just it's very broad. It's if anything, it's kind of like everything that is not being done in traditional science. In the same way, maybe you could define DeFi as everything that's not done in TradFi. So, it's hard to explain what it is, but it's sort of people doing science or finance in sort of new ways.
Was this super connectivity phenomenon that went on the past few weeks, was that an example of less centralized science? Was it a positive example? Was it a negative example? How do you feel
Yeah.
about that
I mean,
whole
obviously it's
development?
cool. I think what I've seen a couple things. Like the first is people trying to validate it in new ways. Now, one of the interesting things about DeSci is like you need to have people have the ability to conduct this. There's many different ways. So like there's examples of science of of DeSci projects where maybe people can contribute in multiple ways. So you can contribute through finding peer review stuff. You can contribute by finding patients to recruit. You can contribute in more ways than just by like they're sitting at a wet lab bench. So, I saw for the LK99 is the, you have all these people and trying to replicate the experiment. And one was I saw it was at Varda Space, and they were trying to replicate it. And this isn't like this is like a well-funded startup, but it's not like a university. So that was pretty interesting. But I think DeSci typically works probably a little bit better when you need to do longitudinal research as opposed to like deep dive on something, because it's just hard to find so in the Psi Combinator group, we have one person who's doing extracellular rejuvenation. But the problem is like, not a problem, but the issue is this guy and maybe a handful of other people in the world are the only ones that know about this, right? So it's hard to really do that in a decentralized way. But there are other things like fecal biotransplant or looking for aliens using software-defined radios that are a bit more easier to scale to different jurisdictions, different areas, different people that are easier. So I think DeSci tends to work well on these sort of a little bit easier projects to run, but maybe not so much on the bleeding edge LK99 or like gene therapy or something like that.
Do you think it's because like the bleeding edge needs like, expertise and lab equipment that like you just can't find off the internet? Or is it more on the collaboration side?
Well, I think it's just on the expertise side too. It's just like, getting someone who knows how to synthesize that is probably not, there's only a handful of people, but I could be wrong on that.
No, I believe it. I mean, I think there are like different ways of DeSci, right? I think like one version of DeSci that we've seen is like, it's like a DAO that helps people get funded, and they're like decentralized in the way that how the funding happens and how the incentive rewards happen, right? But like, that's actually kind of the opposite of what you're saying is like, it's not decentralized in the way that they're collaborating among many people. It's decentralized in like the economic way of like how the funding comes, how do the rewards come, who owns IP, right? It's decentralized in that manner, but it's not decentralized among the scientists who are actually doing the studies. Whereas like you're kind of describing like the opposite of like, you're actually kind of maybe proving their point is you're saying like there are some things that are really hard to decentralize among scientists to do one study because of certain reasons. And those certain reasons can be like expertise is difficult to find. Collaboration is hard among like, like we saw this at Protocol Labs, right? Like collaboration is really hard when your team is like distributed and decentralized across the world in different time zones. And like everyone can do their individual work, but as a team to make progress, you need to like collaborate, right? Or like, if the lab is in a certain area, like you have this high tech lab that can only do some sort of like tech or science, and getting people from different parts of the world into that lab is also not easy, right? So I think what you're saying makes a lot of sense to me.
Yeah, no, I agree. It's like there are pros and cons to being totally distributed and I think it works. I think I don't think there's like a one size fits all. It's like distributed work. Does it work well? Well, sort of. It works well in some cases, but it probably doesn't work well in other cases. And same with DeSci. Does it work well in all cases? Probably. For like software projects, it probably works pretty well, especially when there's not like a native. And it just depends a lot on the leadership of people. Like I've seen projects work really well that are distributed, but then also I've seen projects that really have succeeded because the 2 or 3 people who are working on this DeSci project are in proximity in New York together. And I think there are benefits to that.
Makes sense.
One of the other groups of folks that we had on the podcast, we're talking about this IP NFT as a way to create that economic incentive. And you're working sort of at the data set level as sort of the economic incentive. Could you describe sort of the pros and cons? Like, do you see both scenarios succeeding? Or if the data set itself is sort of the area for economic incentive, do you have any concerns about people taking the data and then sort of sharing it without paying for it? Like, are there loopholes around this, or maybe for scientific purposes, the data set? Tell us more about kind of your approach to that whole problem space.
Yeah, I mean, I think it all comes down to like, I mean, having a little bit of background in in laws, like it all comes down to enforceability on some of these things. Like if someone copies your data set, you're kind of hosed and uses it illegally. If the IP isn't enforceable, especially in a distributed context, it's hard to enforce that as well. So like it sort of depends on, I think data set level fractionalization is like a bottom up thing. And I think, maybe IP NFT is more of a top down thing. And I think they'll probably work together in many ways. So I think you'll need to fractionalize the data set, but at some point you might need a higher level thing. Yeah. So I'd say that's probably how that will work. But I think it's just what's cool about the data set is it's applicable to many different areas. And the IP NFT is also very cool in the sense that you're able to fractionalize it. I think how do you split it up is, you have to split it up beforehand and figure out who gets what, which is great. I think, having that certainty before you enter into the contract will make research more efficient. One of the things that's kind of weird about an academic paper is like who did what on a paper is oftentimes really complicated. And the only way typically, I mean, there is some change here, but the only way is like who's the first author, who's the second author, who's the third author, who's the last author. That's usually the professor. And like that's just like a really weird way of fractionalizing. It should be about who does what. And so, one of the dreams is like, okay, you just look on the chain, who contributed what to the data set, who did what analysis and wrote it to the chain. And then maybe you have some sort of like credit score system where it's like, okay, this person contributed 30% and it assigns 30% of the credit to them, or this person did the analysis and it automatically like gives that person a badge or an NFT that's trusted by this. There's a accredited agency, and we'll just call it NFT University, that grants people that tags people based on the work that they contributed. And then collectively that paper, someone purchases that paper or the data in that paper or the IP in that paper. And then you trust this agency to split up the work, who did what, and then assign people assign people to get whatever incentives or rewards that they want based on their contribution. But we need to build all these tools. This is a couple steps ahead. So like these things have, but that's kind of like the dream.
Very cool. Do you just want to talk a little bit about like DBDAO and how that works?
Yeah.
How it started, how it works, what you guys do today, stuff like that.
Yeah. So DBDAO is like, okay, databases are really interesting, but like there's a couple things that's weird about them. First, they're all just on a central server. You can't, and that central server can be modified, right? So, that's one of the things like why Bitcoin was invented. We each have one Bitcoin, and then whoever owns that can change that number. And that's kind of like bizarre, right? So it would be nice if like every database had that same certainty that if it was ever changed, there would be like a red flag that would pop up or some sort of notification, or it was impossible. And the other thing that's weird about databases is that you give the data away and then you kind of get access to it again, but like you don't get any profit sharing, right? So like you put your data in and then you don't see it ever, you don't monetize that data. So the problem that DBDAO is solving is firstly saying, okay, if anyone modifies the data, we'll let you know. But then the second more interesting thing is like when everyone, say we all three of us put data into a database, and then someone buys this data, meaning it's generates ad revenue, someone purchases it outright, we decide to give it away for free, whatever. Then when someone buys that for $100, each of us who contributed to the data set get $33. And that's cool because now I'm incentivized to put really high quality data into this data set. And so now you have sort of like an economy that's built around data sets. And it's kind of like a cool amalgamation between like Mechanical Turk, like OpenSea, because each row in the database is an NFT. So that's how it's kind of like all tracked, and sort of like a data marketplace where people can like buy and sell data. And when we put these things together, you get DBDAO. And it's also like Google Forms, because the way you put it in is you just fill out a form. Then if your form is accepted into the data set in this structured way, then you get then you get pro rata rewards when the thing is sold. And it doesn't have to be money. It's just tokens. It could be NFTs. It could be credits. It could be whatever. But it just depends on how it's configured.
So the people who put the data in the database, is that like, say I'm doing a study, right? And is it the, whatever, every person, I'm doing like some sort of, I don't know, like study on hair or something. And like every person's like, information is put in, and each one of those people get like, rewards by being in the database? Or is it like three people were doing the study, and the three of us were doing a study, and each of us put in like 100 people in the database so that somebody else can use it, and so the three of us get rewards? Or is it either, depending on the situation?
It can be either. So it can be based on the row level thing, so you can sort of purchase it based on which rows you use, or it can be the whole thing, and that's just sort of a configuration thing. It's like, do you want to purchase data based on collectively, or do you want it to do it? There's many different possible ways, actually. So it could be, you could also do it. Say each of us, say it's a database of colors, and someone submits the color blue, and someone submits the color aquamarine, and someone submits the color light blue, and then someone comes along and submits the color yellow. And yellow is significantly different than all these other colors that are in the database currently. So they should be rewarded more because they added more information to the data set. So you can also reward people based on higher level things like information. But this is sort of a formula, and we have a couple default formulas that basically like collectively or together, collectively or individually. But there are more complicated and interesting formulas that we will add in the future.
So like you could also not just reward like the scientists, who made this data, who did the study, and made this data set, but you could reward like, say these like, I always think about these like life sciences studies or like political studies, right? Like one is software, one is not software. You could reward the participants of the people who participated in the study to give them a reward for their, if something ever happens, like you give them a reward for their time, like we do today with gift cards or whatever.
Yeah. And here you're sort of, you can pay them directly for doing it firstly, but you can also pay them through how it will do in the future, right? So they contribute some certain thing to the data set, but maybe you're sort of tying them a bit more to the outcome, which also encourages them to submit higher quality data. So you're sort
of like equity almost.
Yeah. It's just like partial. They are the holders of those rows,
right? And
if their row is or it's like a listing on Amazon, right? Like if your product is really successful, you're going to make more money. And there's no reason that it's it has to be. People need to ship physical goods, but it can also be for like data sets as well. And so like we have different data sets that that you can contribute to, but yeah, sort of it depends.
There was this other project that had been trying to do this for some time, Ocean Protocol. Do you have any opinions about things that you guys are going to try to do different, that maybe they had a different approach to, or any comparisons there?
Yeah, I think our data sets are a bit more alive. So it's like you're adding a row. We also have this role of the curator who deletes a row if it's spam or bad quality. So just because a row is submitted doesn't mean that they get partial pro rata rewards, right? Because if that were the case, people would just submit a lot of noise to the data set and then try and Sybil attack it. But the way this works is there's a curator who accepts or rejects a different row. And so these data sets are like constantly evolving. Whereas I think with Ocean, it's more like I have a database, I'm going to upload it to Ocean, and then people are going to purchase it or not. But there's no sort of live curation aspect that happens with it.
Very interesting. Okay. It opens up a lot of different use cases then for the data set. If it's constantly being updated, real-time web applications, since you've been so deep building this product in Web3, you're looking at all the different options that are available. And, one of my former projects was trying to build decentralized compute, and we're trying to reinvent all these layers. If you had a magic wand and you could say, I'm going to take whatever exists in Web2 today, maybe even beyond infrastructure, maybe it's Discord or chat or whatever else, and you could reinvent that so that it's Web3 and it's more, let's say, trustlessly neutral, what would you choose? Would there be anything that would help, your type of a project or just a DeSci community in general if it were better available in a decentralized sense?
Yeah. I would say there's a lot we could do if we had like free gas on chain. So that's one of the things that we're sort of limited by. We've solved a lot of the usability issues. What else would be amazing? The mobile thing was we sort of solved that. What else would be amazing to have?
What were some of the sorry to jump in. What were some of the like mobile and the user experience problems that you solved that were problems? Kind of
Yeah,
curious just on that.
yeah. So we basically were MetaMask doesn't work on the mobile. So we re-architected our system actually to have a bit more custodied wallets. And the reason is you can still trapdoor out of it into your own wallet. But the reason is it makes it much easier to interact with the chain. Because a lot of people, the issue is you start using it on your desktop and then you go to your mobile and it doesn't work there.
Hmm.
And then because you don't, and you're a lot, I mean, for me personally, and a lot of other people we talk to, my MetaMask on my desktop is different than my MetaMask on my phone. And so there's just like all sorts of issues. And so we sort of took all the MetaMask stuff and put it at server side and then allow people to sort of go back to the MetaMask level way of doing it.
I was going to say, on that topic of gas fees, by the way, congratulations. It is officially L2 summer now.
Okay,
So
good.
welcome to L2 summer. So we talked about it in the last episode. Coinbase just launched their L2. Lots of activity, these new rollups and things going on. Have you been shopping for L2s for reduced gas fees, Polygon, other things like that?
Yeah. We're on basically Gnosis and Avalanche.
Oh,
So
there you go. Very affordable fees. Okay. You
it's
figure it
still
out.
too high. It's still too high because we want to mint 1,000 rows easily, right? But so that's minting 1,155 NFTs. But that's still costing, a little bit of money. So if you multiply 5 cents by that, it's still too big of a number.
Fascinating. What is the right number?
Well, it
Free?
needs to be
Just
free,
free or
free.
0.0001?
Yeah, exactly. It needs to be as cheap as AWS.
Well said. Ishan?
What was like when you're looking at an L2 for this kind of like, minting NFTs and rows and everything? What aside from gas fees, what were the top things that you were looking for?
No, that was it. It was just
That
gas
was it.
fees.
Okay.
Yeah, I didn't
Okay.
care. Like I just deployed a contract on each of the subnets, on each of the nets, had a Google Sheet and looked at how much it cost. And that was the only thing that mattered.
That makes sense. And do
Yeah.
those NFTs, like, do they live on like IPFS or Arweave
Yeah.
or something like that?
Yeah,
So that
yeah,
you
yeah.
don't have.
Yeah. So we basically upload to basically here's how it works is you have a JSON object as the row, and then we encrypt certain parts of it. So if you have an email address or a social security number, hypothetically, you would encrypt that first. Then you would upload that to IPFS. We'd get the CID. We put the CID in the NFT, and then we upload the NFT to mint the NFT on one of these L2s.
Very cool. That makes a lot of sense. So like, do you, I actually kind of want to hear more about like the decentralized science and the DBDAO side. Do you have like a real example of something that you guys have like I don't know, anything where it's like a study where like, there was like this big data set and these many came from like DBDAO or people use DBDAO or something like that, just so that we can go from a little bit from like abstract to concrete for the listeners, but also for me.
Absolutely. So there's this one project called HairDAO. And HairDAO is trying to democratize hair loss research. And the way they're doing it is they're sort of looking at all these different drugs, probably some that didn't get fully through a clinical trial or things that are sort of looked at online. And they're trying to find if any of these maybe given a more targeted patient population or other things, changing the dosing. I don't actually know if they're changing the dosing, but they're looking at other things, help to contribute help solve hair loss. And what's interesting is that, so the way they're doing it is they have they minted a token, and everyone who contributes a row into the data set. So they're asking people to upload their age, their gender, the drug that they're taking, how long they've taken it, pictures of their hair, their genome if they want to, stuff like that. And what's really cool is if your row is accepted, then they give you you get an NFT with your data in it, and they give you also some amount of hair token. And the other thing I wanted to say is what's cool is like now in your wallet is this row with your data. So in theory, if you go to another website or another project, your data is sort of all the rows that you've contributed to different types of databases are sort of sitting in your wallet in the same way like all your NFTs are in your wallet. So I think this is really cool down the road also, or when you go to a website, now it already knows my name based on my wallet because it's sort of sitting in the wallet, or maybe it knows my profile picture, or it knows my favorite types of food, any types of information that you'd want that would be, I'd be okay with sharing publicly, like on a public Twitter account or something like that. So that's kind of like a concrete example. We have other people who are doing distributed science or distributed sociology research on it, having people fill out, they're doing DAO research. So studying how science happens, how political views change, how political views in different DAO. What are the political views in different DAOs? So they have people filling out this survey that they've created. And based on the survey response, they get the NFT, which is then she studies all the different responses. We have other people who are doing cannabis research, and people are uploading different types of the genomes for different types of cannabises and how they taste based on it. So it's kind of like people are filling out these forms with different types of information and then getting rewarded for that.
Very cool. So what part of like decentralization or Web3 do you think like has the biggest effect on like the improvements of like data gathering and data analysis and rewarding people for, higher quality data?
Yeah, I think the first one is rewarding people. So that's the main thing that will differentiate the next wave of science from the traditional wave of science. And I'm sort of calling this like incentivized research. Sorry, incentivized science. So like we have distributed science, obviously, but I think there's this new thing that I'm trying to push called incentivized science, where it's like you're incentivized to do so. You're incentivized like in the like a labor market or a marketplace. I think that's the main thing. The other one is curation. So when people are putting data together, sometimes it needs to be curated to remove spam or things that obviously are incomplete forms. And this happens a lot in scientific research, is like some of the data points, or maybe the machine was broken, or, a lot of different reasons. So curation, paying people for curation. Then I would say like provenance. So like being able to track where data came from will be important. So with AI and with synthetic data sets coming out, it's going to become more and more important to know, is this synthetic data or is this real data? And one way in which you can do that is by checking its provenance on chain. So you can say like, oh, this came from a person, and then the person, they have a WorldCoin ID or something, and they're a real person or something like that. It's going to vary a lot based on it, but at least you'll be able to check it, and people won't check it people won't check it themselves. There'll be some sort of tool that will automatically check this sort of thing. So provenance, determining provenance for data would be another important thing that I see coming. And provenance is also sort of related to like data worthiness. Like we've seen a lot of issues with the trust around data. Like Stanford's president just had to resign because the data analysis wasn't connected to the actual data set, and it was sort of fake. And this could be, in theory, checked using a tool. If you could just look at the paper, you just plug in the paper, you look at the data set, you run the same analysis on it, you check that the image comes out the same way or the analysis comes out the same way. And this is all sort of this reproducibility and provenance is given to us by the data provenance infrastructure.
Very cool. I feel like, I just learned a lot about, again, we had second decentralized science topic, but like learned a lot on like on the data side, right? Like I feel like we'd heard a lot about like on the economic side, but there's some stuff on the data side that I'd really never thought about.
Yeah.
One other topic that comes up a lot for us is this global regulatory environment of crypto and Web3. And as a person who's starting a project in crypto, you're based in New York, is that right? Based on your cap, I'm going to make that.
I'm here from time to time.
Yeah.
Oh yeah, I am wearing the New York hat. This is, but I like corduroy is my favorite material, so that's
corduroy is very in fashion right now. It's very on trend. So well played. But no, yeah. So as a builder in the space, there are certain challenges building in the US. There are other places like the UK and Asia that are, say, they're evolving more quickly in terms of their regulatory frameworks. Do you have any opinions about how it's changing? Are you comfortable with how it's happening in the US? Would you like to see any differences or any changes in regulatory stance towards crypto and Web3 projects?
I need to, I don't know. I haven't gone into this field enough to have an opinion on it.
That's fine. Hey,
yeah.
Go ahead. Yeah.
Luckily, it sounds like it hasn't affected you yet.
Right. So, that's what I was going to say. If you're happy, then that's good.
We're doing the data stuff. We're not, we're not touching. We're mostly interested in data sets right now, and building data sets and not so much of the other things.
So you're not going to be issuing a stable coin anytime soon that
exactly.
we should
exactly.
YOLO into.
Yeah. Exactly.
Fair enough. Okay. Well, one last question for you. Specifically, we're talking about AI, and I just want to briefly get your perspective as a person who's done some research in the space. There's a person, George Hotz. I don't know if you followed him in an AI space. He's coming out with this company called Comma AI, where you would have your own personal AI training software, hardware, maybe in your house. And his thought is if there's going to be a super intelligent AI, if I can have my own personal AI, I can align it to what I care about. And maybe that's some kind of a defense mechanism against future. There are other projects that are working on decentralized AI training and lots of different approaches to this. Do you have any concerns about the future of AI? Do you think decentralization of Web3 offers any potential solutions to those challenges?
Yeah. I mean, I think the most dangerous thing when it comes to AI will just have one monolithic AI that controls all. And I think the safest thing is having millions of different AIs that are each trained on different data sets and are personalized to each other, are personalized to ourselves. And, his new company, I think, Teeny Ground, I think it's called, will help with that will help with that. I think you don't need the hardware necessarily in your own home. I think you probably have it in the cloud. But what's nice about having multiple different types of AIs is then they will bicker in the same way that humans bicker. So like it will prevent any one AI from becoming all powerful. And when you have thousands of AIs that are each competing with each other, they sort of neutralize each other. And that would be my guess, which is the safest way forward. And, somewhat ironically is the way to do that is to sort of unregulate it a little bit so that anyone can have it. And then everyone is sort of fighting and bickering with each other, which will create a safe system, as opposed to trying to make one AI the winner. And then that thing is really dangerous. But that would be my guess on how to safely go forward is sort of, it's like Congress. Like if you really want Congress to do nothing, you just let them all talk to each other. And then they say, slow down and stop and everything's safe. Whereas if one person's really powerful, then that's the dangerous part.
I 100% agree with that. And I think that's like the most coherent, like opinion of unregulating AI, like I've heard yet.
Awesome.
Like, people are like, oh, like it's bad for business, bad for innovation, whatever. But like, I think that's the best one and makes the most amount of sense to me. Out of like, and out of anything I read or anything I've heard on, podcasts or YouTube or whatever.
Thank you. I mean, the other thing that's interesting is we touched on this a little bit earlier, was like the enforceability of some of these things. So, a law is only as good as how enforceable it is. And so here's the issue is that like the US is you can enforce an AI in the US, and everyone wants the US to be healthy and successful. But then another country comes along, is like, we don't care about, like, we don't have the same norms as the US. It's like another country, and they're more about using it for surveillance or AI for that. And we need to be able to compete with that. So it's important not to only think about how AI is regulated from an internal US perspective, but also how, how the US projects its AI capabilities to other places, because they are going to butt up against each other internationally as well. So I think it's important to think both like from an internal perspective, but also from an external perspective, because we want many different AIs to happen in the US, but also many different AIs will happen throughout the world. So we need to think about both of those cases.
It's a great point. It's like trying to outlaw Bitcoin in some sense. If you have access to the internet, and your home country says you cannot train an AI, super intelligence to do what you want. Well, if you have a VPN to a server in Hong Kong or something else, you could train it to do whatever you want to do. So how could you truly limit a global internet just purely based in the US?
Exactly.
I don't know. Maybe is it enforceable? Maybe it's not. I don't know.
It's not, but it does stop, like a normal person's not gonna, like, they're gonna be like, if I have to VPN into another server in a different country, learn the technical parts just to run my own AI or train something, right? Or companies want to do it, like I do think it like highly hurts that ability to do that, and like it discourages that ability. So like most people don't, and if most people don't, like, I mean, from an innovation perspective, or like AI, developing AI and making progress in AI, it kind of hurts. Like, whichever country like sets up regulations, I guess in this case, the US, since they're all here. But yeah, I guess I think the cool thing about the internet is, and especially decentralized, is with the VPN, you can, basically do anything.
Agreed. We'll see. I mean, unless they cut off the network connection, but maybe we have a
the great
Tesla
AI of America,
Skylink or whatever, Skylink by that.
Very good. Well, I want to wrap up, Michael, and give some space to hear about what people can do to get involved in DBDAO and what they can do to get involved in DeSci NYC. But before we do that, I just want to say, Ishan, anything else that you think we should bring up while we've got Michael on?
No, I think we had a great conversation. Michael, thanks for coming on the show, right? Like, I'm sure the listeners learned a lot. I learned a lot. So yeah, just overall, just great to have you.
Overall calls to action would be check out DBDAO, see if there's any data sets you want to fill out. If you're in New York, go to DeSci.nyc, come by one of our events. And if you are international and you are interested in getting involved in DeSci, check out Sci Combinator, psicombinator.xyz, and apply to our next cohort of DeSci projects.
Brilliant.
Woo.
Thank you so much.
Yay.
We're going to include this in the show notes.
Awesome.
And we're going to keep showing it. Beautiful.
Excellent.
Michael, thanks so much for coming on today. Pleasure as always.
Yes, likewise. Bye.